Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. So today we've got Anthony who has completed the course ROS 2 Navigation. So what we'll do first is we'll see a demonstration of his project on the real robot, and then after that we'll get into the details about how he managed to make the robot navigate. And as usual, we'll get to ask him a couple of questions towards the end. So I will now hand over this time to him so that he can begin his presentation. All right, Anthony, whenever you're ready.
Okay. Hello. I'm still waiting to connect to the robot. So in the meantime, I'll just kind of go over what the project was. So this project it's the ROS2 navigation. So there was 4 main sections we needed to cover. The first one was mapping, so just making a map of the environment and then saving it for later use. Then there was localization, which is basically just getting the robot to kind of familiarize itself with the environment. Then there's then there was path planning, which is like once we set a goal, which we'll get to in a little bit, it basically like calculates through some algorithms how to get to that spot without crashing into things. And then there was the navigation stack where basically like when we set a goal like from some spot saved, it would be able to automatically go to it.
Okay.
But I'll get into how I did all of that and how it all kind of works.
All right. No, it's fine. It's fine. All right. So you would have to be explaining what you'll be doing, which terminals you're opening, and what are they for?
Sure. So right now I'm just building all the packages. So as I said earlier, 4 packages. 3 of them are for the local. There's 3 main ones, which is the localization, path planning, and mapping, localization, path planning. And then there's a custom interfaces package where that's like where our services, which was needed for part 2. I'll get into that in 1 second.
Okay.
But right now I was just setting up all the packages, like building them. Okay, so I already saved the map in the simulation. So just to save some time here, so we're just going to get into the localization, and then I'll touch on the map part of it in a little bit.
Okay.
And I just saved all of the terminal lines that we need to use because it's a lot of typing, and like I said, I'm trying to save time.
Okay.
So right now I'm going to launch the project localization file and like that project, and that I'll show you how that works in 1 second. I'm just going to go ahead and launch the RViz as well so we can see what's going on. And I source all of this just to make sure we don't have any silly errors pop up.
Okay.
Probably need it at least for the RViz, but just in case.
All right.
Okay. Then from the unit notes, we were able to set up a configuration that we don't have to go redo 1 by 1 all these laser scan particle clouds. We're just able to watch it pretty fast.
Okay.
So I'm going to launch the localization terminal. Yeah, the localization terminal. And this is basically just kind of setting the robot up in the RViz so we can start seeing it basically.
Okay.
Then so right now, I'm going to test that the localization actually worked. So I'm going to move this to a spot that we kind of place easily. So using this 2D pose estimate, the robot's somewhere around here. So I'm just going to click it and show the orientation like that. And to make sure that the localization works, we're going to see all these particles go from like a scatter basically to a lot more condensed.
Okay.
Just moving the robot around, it should be like that. And as you see, the robot, the robot is getting a little. All the particles are getting closer. They're not so scattered. So this is basically just it collecting the laser scans from the lidar and kind of familiarizing it with where it is in the map right now. Okay, so that's that. Okay. I'm now going to run. So we needed to save 3 spots in this project. So I'm going to go and run that code now. And this is basically just to show that the robot is able to not only save spots, but also go to it once called in a separate file for another section of the project.
Okay.
So this is just launching that file that I made to be able to save the spot. So right now I'm just going to move the robot to where the spots needed. And the spots we needed the instructions are in the, I'm sorry, where we need to go is in the instructions. So I'm just going to assume that you understand which spots are needed. Right now, I'm just going to call the custom interface the service to be able to actually save the spot to a YAML file.
Okay.
And again, I'm just sourcing just to make sure that all the terminals, because we have to open so many, actually understand like what's all the changes made basically. Because it's kind of like setting up the settings.
Okay. Okay.
So I'm going to click this 2D pose estimate here, drag, double check. So drag on where I think where the robot is. And this is setting the pose basically, and this is what's going to save to this spot, this service call right here.
Okay.
Okay, pose recorded. So I'm just going to do that 2 more times for the 2 other spots we needed. And the way that works is that when I go back to it, that tool is basically using the initial pose topic, and my service, my service is subscribing to that topic. And once I call the service, it gets the coordinates and is able to pull them and save them into a YAML file, which we will use for the path planning
Okay.
portion of the project. And then depending on where the robot is, it'll use some other code that I will talk about in a little bit.
Okay.
That will allow it to basically get there no matter where it is in the map. Oh, oops. I forgot to readjust the. There we go. Now I will run for corner 2.
Okay.
Which is what we needed to label it. Okay, then we have 1 more spot to go to. A little time consuming, I apologize.
It's all right.
Okay. And just call this one pedestrian. Again, this was in the instructions.
Okay.
Okay. Oh. Forgot to set it. It might work without, but I've had better results doing it this way, just reusing the 2D pose estimate. Okay. Because when I did just calling the one time, like from earlier, it would keep for some reason the first position. Like it wouldn't update for some reason, and I'm not really sure why.
What do you mean?
Having to redo it is.
You mean redoing the localization or?
Yeah, the pose estimate. So like if I start moving right here, for whatever reason, at least in the simulation.
Yeah. So
let's say I move to the other side of the map.
Yeah.
It wouldn't give the coordinates for here, right? It would keep it from the spot I originally set the processor to.
Oh, okay. So
Maybe that is how it's supposed to work. I just assumed it would be like constantly updating. But because I have it the service set to initial pose and not MCL pose, I'm assuming that might be why I wasn't able to get the updated.
Okay, I see what you mean. All right. So it's like you have to move it away
Yeah, because right
first,
now, like,
and then pick that spot as the beginning.
yes, because I'll show the code in a little bit, but this was basically just setting up the points, and because it says initial pose, that's what topic this 2D pose estimate uses.
Okay.
Whereas the MCL pose is just like no matter where you set it, it's where the robot actually is.
I see. All right.
In the map.
Okay.
Okay, so we got all 3 spots saved. So now I'm going to launch my path planning, which is basically just a lot of YAML files that are in control of how to go from basically point A to point B. I'm gonna go ahead and launch that. Okay, let's get launched. So I'm just gonna move this around a little bit more now, just to make sure the robot gets localized as the particles are still a little bit scattered. But while I do this, I'm going to just send a test goal, just from the artist point of view, just to show that the path planning is working by itself, and then we'll go to the 3 plots that I saved, and hypothetically it should go to them and work. Okay, so the particles are a lot tighter now, so we're able to, like, the robot knows basically where it's at. So I'm just going to gold close. I'm going to go here, and as we see, it's automatically going there. Avoid the obstacles using some of the files were provided. And yeah, okay, so now the real test is actually going to this position. So like I said, there was 3 spots, corner 1, corner 2, and pedestrian, which you saw me go just kind of run through. So now I'm going to actually try and run the Python file, Python script that'll actually make it run to that corner.
Okay.
Which corner I want. I'm just going to open another terminal, source it real quick, and then hopefully it actually goes to that spot. Accepted. So corner 1, like,
Oops. Okay.
I don't know why it did not avoid that.
Let's see your RVs to just figure out what how it is localized. Okay. All right.
Yeah.
Try setting another goal.
Actually,
Let's see.
the orientation's a little bit off. Yeah, I'm just gonna move it a little bit more because for some reason maybe I just need to make it a placement, but the orientation is slightly off.
Yeah, and you can see also your robot is got it's not just orientation, right? It's the what it's seeing, right? The walls are not completely superimposed, right, on the actual map. So that also has got something to do with
oh yeah, that's a good point.
Yeah, it's like it's navigating in an inaccurate map, right? So that's another thing that you might also have to consider.
Yeah, that's a good point, actually. In the maps I was using before, which actually I'm surprised it's not flat, but like all this was like a perfect square. Well, and there's one more obstacle it didn't detect here for some reason. There's that one, and there's the 2 little.
But that goes back to how you built the map, right? So is this the original one that you built, or you try to build another one?
Well, it was the simulation one.
Yeah.
But there was still two spots here. I'm just not sure why there's only one showing right now.
Unless you changed it, it shouldn't change. It doesn't change. Yeah.
Yeah, I'm a little baffled right now. But we did see that it did go to the corner 1.
Yeah.
So
let's try corner 2.
Corner 2, which is over here. So not 100%. I think I had it closer here, but
Yeah.
maybe just I don't know. Maybe I messed up the pose estimate, but it's
Yeah.
pretty close to
Yeah.
where it should have gone.
Yeah. Again,
So
it
we
comes
go to
back
the
to the
pedestrian.
issue we've been talking about it being properly localized, right? That's number one. Then number two, the quality of the map also has got a lot of it's got a lot of effect on how it's going to navigate, because if it's not accurate, um, it's going to struggle. You know.
Yeah, I probably should have just built the map again from scratch. I was just trying to save me time, but
Let's
at least the goals were met pretty much.
let's go to
Okay.
corner three and let's see
Oh,
the pedestrian
this was
zone.
it. It
Oh,
was
okay.
the
It's
pedestrian.
so it got there
Yeah,
with
it already moved there.
deviation a little bit. Yeah.
Yeah, a little bit, but
All right.
it's pretty close.
All right. Is there anything else you wanna get
Okay,
into
so,
detail about the code?
well, as far as the demonstration portion, I think that's it. We saw that it was able to save the 3 spots,
Mm-hmm.
go to them, slight deviation, but
Mm-hmm.
the goal of the project was done.
Mm-hmm. Okay.
I can just kind of talk about how I
Okay.
solved it.
Sure. Sure. You've got 4 more minutes.
Okay, I'll try to be quick. So the custom interfaces, we needed to make a service basically to accept the the request and response. So the format we needed was given already. So I just made another package. Didn't want to put any weird bugs that I dealt with before. So I just made a new package, a CMake, and I needed that from the ROS 2 basics course. So I was just able to make that. The project localization, so that's like I said, where the robot actually gets localized with the environment.
Mm-hmm.
So there here is the AMCL. So it's basically like the algorithm is telling it basically like where it's at in the environment.
Mm-hmm.
The spots YAML, this is the 3 spots I saved. So these are just the orientation position.
Mm-hmm.
And one little bug, or not bug, but one problem I faced for a while was the orientation was all just one value. And that was because I didn't know in the ARVIS, when you set the pose estimate or the goal pose, I didn't know that you could hold down like the arrow. So I just kept clicking it. Like I just kept clicking one spot like that. Whereas I wasn't giving it like a relative coordinate frame, if that makes sense.
Okay.
So I was able to figure that out. And that's how I was able to get that. Okay, the spots to file. So this is the word I was calling to save the file, save the spots.
Mm-hmm.
Corner 1, corner 2, and pedestrian. So yeah, this is the initial pose. So that's why I had to redo the pose estimate tool
Mm-hmm.
every time I move.
Can you show me what your map
Without
looks
getting
like?
too much
Um,
the map.
yeah, the map you created earlier on, because I think the code details are quite good now.
Okay. Why it's not running? I can just quickly run a new map. I don't know why it's not opening this one.
All right.
One second. Sorry. Around.
Are you having to rebuild it again? I see.
Yeah, I don't know why I couldn't open the other map unless I was just doing something.
Okay, maybe
I don't know what's happening here.
you should be able to open it with an image viewer, but it's fine. Don't worry. it would be nice to see how it differs, or if it was the exact same map you were using, and also to just understand why did we
Okay.
have missing
Yeah.
obstacles, right? So that's what I wanted to understand, and I think you can see
Well,
from the one you are currently
that
viewing
was because
that
yeah.
big
So the
obstacle is
reason we
visible.
didn't have the other obstacles
Mm-hmm.
is because I did it in the simulation, and in this real robot, like in your guys' office, there's a lot more obstacles. But I didn't think that was a problem because the path planning package has some tools in there where it should avoid them no matter what, right? Because
I see.
it's using the lidar. So that's why I
Yeah,
was like, okay, it's
I
gonna be
see.
a problem. And I was trying to save time.
I see.
It said
It
doing it
answers a lot
anyway.
of questions. Yeah, it answers a lot of questions. But what I would advise is, when you move from simulation to real, you must try by all means to at least remap. That's what I would advise, because simulation is not going to be exactly be similar to the real environment, right? So it it is very much advised for you to rebuild the map using the real robot, right? So that you make up for differences and deviations that you might encounter in the real on the real map in which it's going to navigate in, right? But yeah, it does answer a lot of
Yes,
questions.
sir. And that makes sense. That's all me. I was just trying to make sure the demo went a little quicker.
Mm-hmm.
But I guess I should have just done that.
I see. I see. Yeah, because you also have things that don't show up
It
in
is working.
simulation. For example, drift, right? Yeah, you're not going to have as much odometric
Mm-hmm.
drift in simulation, whereas in the real world, your robot will slip. It might encounter surfaces that are not as that might not give as much traction, so it will deviate from
Mm-hmm.
what it looks like in simulation.
Mm-hmm. Yeah, yeah, I understand.
All right.
Um,
Just to ask you a couple of questions, Anthony. Let's see which ones exactly. All right. You spoke about the MCL, right? Can you just take us through theoretically what is the purpose of the MCL node in this whole navigation stack?
right. So the AMCL is basically a algorithm that runs, and using the lidar or like whatever sensors, it's able to like familiarize itself with the environment by getting a lot of the samples.
Mm-hmm.
And after a lot of samples, as we saw, like once we started moving the robot a lot more, it was able to actually find itself and be like, okay, this is where I actually am, right? A little bit percent error, right? But pretty much just understanding where it's in the environment.
Mm-hmm. Okay. And
So like, from the start, we saw that it was a little confused, but after moving a little bit and gathering some data, it was like, okay, I see. This is where I'm at.
okay. And what is the purpose of the particles?
The particles,
Yeah, that you.
it's yeah, the particles are just like a rough idea of what the robot is, like with the size and all that. And if we go to the cartographer Lua file,
Okay.
the oh wait, this one.
I
I
think
apologize. That was
okay, I do understand what you mean, that they are used in the figuring out where the robot is actually is, but the actual word I was looking for is their sampling points, right? So the MCL,
yeah. That's what I was trying to get to. I was trying to find this part right here. Is that,
yeah,
yeah, their sampling points. So
yeah,
the more you have, the more accurate it will be.
exactly,
So if we were to increase these numbers or decrease, it would change the accuracy.
right,
But with some real world costs, like it having more sample points is like more memory and things. So depending on like what you're working with,
your
how much RAM
hardware.
and stuff like that you do have to factor that in. But in this case, we didn't have to worry about
Mm-hmm.
things like that.
Mm-hmm. I see. All right, Anthony. I don't see myself having any more questions from now on, but very it was a catch 22, right? There are some things that didn't go so well. There are some things that you kind of took shortcuts on, but it was a good presentation. It showed that you do understand everything that was supposed to be done. So very well done on that. I also liked your answers to some of the questions. So a
Mm.
very warm well done on that one. Other than that, I would say just hang on. We wrap up here, and then we can finish our conversation on Zoom. All right.
All right, sounds good. Thank you.
All right. All right, everyone. So this was Anthony's presentation. Congratulations to him for taking us through the whole navigation stack and showing us how it works. It could have been more accurate, but we do applaud him for that job well done and also clarity of the whole process in general. So a warm congratulations to him. And to all those who would like to try the courses that we offer certification on, we highly encourage you to do so. And until next time,